Hello class, this is Professor Hiley and I'm looking to make a video and post them on YouTube as my attempts to use our college software have kind of ground to a halt, and so I'm trying this out to see if we can do it this way. So what I want to do is just start with a little introductory video on differential equations, higher order, which is where chapter 4 begins. And I want to talk about something called the existence and uniqueness theorem. So we're going to be talking initially in this section about two types of differential equations. And so we want to know, right, if I'm presented with a differential equation, is a solution going to exist? And if it exists, is there a unique solution, or is there a whole bunch of solutions? So in general, right, the chances of having a unique solution are going to require us to have some kind of conditions, initial conditions that we're working with. And so there's two ways that those are presented. I'm going to discuss the first one in this video. So we're looking at higher order differential equations, and for right now we're going to concentrate on linear higher order differential equations. And so because obviously when you go to nonlinear, the complexity increases quite dramatically. So we're going to look at this existence and uniqueness of solutions to a linear differential equation in an interval I. So always when you talk about a solution to a differential equation, that solution exists in some interval. That interval may happen to be negative infinity to positive infinity, or it may not. So, and also if you switch intervals, it could change the solution, right? But how do we know, number one, is there going to be a solution? And number two, is that solution unique? Okay, so well, first of all, let me present what we mean by a linear higher order differential equation. And this will be very much similar to we did first order earlier in the previous chapter, right? Chapter 2, we did first order, right? And first order, right, looked like a1x, y naught, y prime plus a0x, y equals qx, right? This was our first order kind that we looked at. And this idea of a higher order is just going to be an extension of that same concept. So this is an nth order, right? Because that's an n. So this is nth order. Because of the n, that's the nth derivative of y. And we have coefficients in, just like we had coefficients in the independent variable in front of these, equals this. We have the same concept here. All these are only in terms of x. So a n minus 1 of x, a n of x, all the way down to a0, only function of x, and equals at most some function of x. So this is what we mean by a linear nth order differential equation. When g of x happens to be 0, we call that homogeneous. And we will start with getting solutions to homogeneous equations. And in addition to this equation, we're looking at the initial value problem. And what that means is that we have a function, this equation, right, has some conditions associated with it, that we have the function itself, and each of its derivatives are defined at some x0. And important here is that x0 is an element, or it belongs belongs to our interval I. Obviously, if this x0 were outside the interval, then we picked the wrong interval. So functions are restricted to intervals, and so we want to make sure that this initial condition is in that interval. And so what are the conditions for this to have a solution and a unique solution? Okay. Well, first of all, we need an of x not to equal 0 in I, right? So we don't want, this is, if this is 0 somewhere in the I, then we're going to be out of luck, right? And specifically also, we need an of x all the way down to a0 of x and g of x to be continuous in I. So whatever our interval I is, all these coefficients have to be continuous for this to have a unique solution. Okay. And so then so I'm going to call this linear equation that I defined here, I'm going to just call that 1. Then 1 has a unique solution. And so if we have all these coefficients being continuous all the way over here in the interval with an initial condition that's in that interval, then we're guaranteed that there's going to be a solution, and that solution is going to be unique. And with the next video, I will pick a specific example, and we will milk that example for all it's worth to show you exactly how this plays out.